This is problem 3 on practice exam 5 of chapter 2 in the book Problem Solving with Differential and Integral Calculus. We're going to put on our math hat here and take some derivatives of purely mathematical functions. A is y equals 4x cubed minus 3x, and B is y is 4 times the quantity 1 minus e to the minus 3x. There are rules for calculating these derivatives, but we're not going to follow them. And we're not going to use them. We want to understand what's going on. We don't want it to be magic for us. We want to see the wheels turning. We want to see how it works. We want to understand what's going on. So the question is, I have this function, 4x cubed minus 3x. I'm going to have x and I'm going to shift it by an amount dx. How does the value of the function change? So we're going to substitute x plus dx in for x in the normal equation, and we're going to get a shift in y. The original y plus some dy when we shift x by dx. And the question is, this is the fundamental question in calculus, how does the function change when we change one of the parameters? What's dy? So we start by performing this cube, and we get x cubed plus 3x squared dx plus 3x dx squared plus dx cubed, and then we throw away the higher order powers of dx. Both dx squared and dx cubed are 0 compared to dx. They're infinitely smaller than dx, so we just throw them away. And we have this. And you can see y is 4x cubed minus 3x. That's the function. So we can subtract that function from both sides and get just dy on the left-hand side of the equation. And that's 12x squared dx minus 3 dx. If we did it right, that is the derivative. That relates dy to, I'm at x, I change by dx, how much does y change? That's my dy. Starting at any x, shifting over an infinitesimal amount dx. Let's check it. So we're going to plug in x equals 2 and a dx of a small dx minus 0.00011 10,000th. So we're going to start by using the normal equation. And we're going to see how much it actually shifts. So when we plug in x equal 2 to the normal equation, that's 2 minus 2 cubed minus 8 minus 32 plus 6 minus 26. Now we're going to plug in minus 2.0001. We stick that into the normal equation and we get minus 26.004500. So the value of y shifted by minus 0.004500. That's how much it actually shifted. Now we're going to see the shift with the difference equation. The derivative. Let's see what the derivative gives. So we're at minus 2 and we're shifting minus 0.0001. We want to see what dy is. So we plug in minus 2 for x and minus 0.0001 for dx. So 12 times, that's minus 4, well, that's plus 4. So that's minus 0.0048. That's plus 0.003. So minus 0.0048 plus 0.0003 is minus 0.004500, which is exactly what we got by using the normal equation. Twice, it works, we're happy. On to part B. Again, we're not going to use any rules to calculate the derivative. We're just going to change x by dx and see what happens. So y plus dy is 4 times, we just stick in x plus dx up here. Now we're going to subtract y from both sides, and y is just 4x cubed minus 3x. So that gets rid of the y on the left-hand side. There's the y we just subtracted. Let's distribute the 4's in there. Now we have a 4 minus 4, that's 0, that's easy. And get rid of that. And we have this. We can rewrite this exponent like that. And we can factor out 4 minus 3, 4 minus 4 e to the minus 3x. We can factor that out. And we have this. Now we have this crazy thing here, e to the minus 3 dx. That exponent is infinitesimally small. E to the 0 is 1. All right, so this is going to be a little bit less than 1. We have an infinite series. We can get that value. So e to the minus 3dx is 1 minus 3dx. A little bit less than 1. We can substitute this in for e to the minus 3dx. There it is. So it's 1 minus e to the minus 3dx. We're substituting in 1 minus 3dx. So we have 1 minus 1 minus 3dx, but that makes it a plus. So we have 4 e to the minus 3x times 3dx. 12 e to the minus 3x dx. That is the derivative. Hopefully. We can check it. Let's choose x equals 0 and dx equals 1/10,000. So the value of y when x is 0, e to the 0 is 1. 1 minus 1 is 0. So that's 0. That's nice. Now we stick in 0.001. We're just using the calculator here. We're using the normal equation. We get 0.0011998 for the value of y. So since it started at 0, that's the shift. 0.0011998. Now we can use the derivative, which is 12 e to the minus 3x dx. We're going to plug in a 0 for x right there. And for dx, we're going to go 0.0001. And we get 0.001200. And the difference was 0.0011998. Those are very, very close. It works as expected. We're happy. Anytime you spend trying to understand something at a fundamental level is not wasted. It's easy to say, oh, just give me the rule. I don't want to think about it. But then you're like everybody else. You don't understand what the heck's going on. It's a great investment in your future.